Hi everyone, this is Omar Al-Twaini, and today I am going to present the updated version of LaGriSU landslide, grid units, and slope unit extraction tools. Would like to mention that there are major updates, and the new version is available through the GitHub website and also in the Udemy course. So, without further ado, let's get started. At the end of this course, you will be able to produce a group of results, which include the landslide-free zones using two methods. If you are using point landslide inventory, you will be able to produce the grid units for the landslide inventory and slope units for the landslide inventory. And if you are using the Polygon landslide inventory, okay, which is the most common, either you have the points or the polygons, then also you can be able to use and to produce the grid and the slope units. And then you will be able to produce the binary inventory, okay, which include the value of 1, which is the landslide location inventory, and combined with the landslide-free location inventory. This is for both, for the grid unit and for the slope unit, using also the points and the polygons. Okay, and then the final products will be the training and testing data, that it will come as a .csv file format. Then you can use it later to process the landslide susceptibility maps using the machine learning algorithms, which can be available also in different courses that I produced. Before we get started, actually, I want to mention that this is a 2022 version update for the slope and grid units extraction, which already was available last year on Udemy and as well as GitHub website. But in this version, quite amount of updates actually carried to make the tools more robust, as well as I collected the questions and inquiries for all our students for the last year to produce the enhanced version that it's work on most of the most recent version of the QGIS, as we will mention later on, as well as enhance the algorithm in case of having some of them having problems with the version, or there are some instability when we do the process for like the processing time and also the amount of the capacity of the limited RAMs that you are using. So to start with the new features, first of all, we introduce here two methods for extraction landslide-free areas. As we know, when we deal with the machine learning, we need to have our binary data, which is presented by 1 and 0. The 1 represent the landslide locations, which can be points or polygons, and then later on to be converted into a grid mapping unit, as well as we need to have the landslide-free areas, which are represented by the zeros. So there are too much theories actually in the literature, but the most common applications are using the two methods. The first one is the buffer zones. The buffer zones, which is talking about create safe areas around the active landslides locations, or for example, in case we have a single landslide, or we have a landslide event. So the events, that means we have one event of rainfall that lasts for like maybe 2 days, and we have after that there's 2 days of rainfall with high intensity produced like maybe 100 or 50 landslides. So in this case, in both cases actually, the safe zones are the areas around those landslides location which are not, which didn't witness any landslides before. And the second assumption is to have the slope value threshold. So this second assumption or hypothesis was applied on the previous version, which is we assume that we have a specific threshold that, like, let's say the slopes from 0 to 10 that never witnessed landslide according to the inventory that you provide. So in this case, this 0 to 10 degrees, we can assume this is a safe area, which is more caution or more let's say conservative compared to the buffer zones, because in the buffer zones we might have also critical slopes and it didn't witness landslide, but the low slopes or the threshold, the slope threshold, that we are sure that the probability of occurrence is very low because it might be flat or semi-flat areas. However, in this version, in the buffer zones, and the second one with which is slope threshold, I integrated also the first one. So the second tool, which is integrated the slope threshold and buffer zones. Okay, so you will, if you follow the second hypothesis to produce landslide-free areas, you will have the landslides areas which is within a specific buffer and also within a specific range of slope. And one of the drawbacks that we also fixed here, when we produce slope units, which is also in the literature, there are some issues about the homogeneity and the shape sensitivity. What is this? So you know that the slope units, they use tools or any tools that exist for producing the slope units, try to find or to divide the slopes into smaller bodies. Okay, and this is with the different sizes by cutting along the ridge and the valley lines, and this is, as we know, it's a hydrological process. So in this case, what happened, some of these boundaries, as we said, when we divide the slopes based on this hydrological analysis, we cannot identify the boundary between the horizontal and the inclined surfaces. So what happened? This will generate large number of parallel river networks. So which is, we will see them, they look like long elongated shapes, and it's clearly that they are not representing slopes. So but in this case you need to fix them manually, but in this version that we overcome this kind of error. And actually it's happened because of the inconsistency between the dam resolution and the terrain complex, okay, and scale. So if you are using a small area but your dam resolution is very low, so then you try to have a meaningful relationship, but the dam will not give you the proper shape for the slopes, or the opposite as well. So in here as well, one of the new features that we are now able to deal with the points and polygons together. So if you have points represented landslide inventory and or polygon representative of landslide inventory, both it can be used in this current tool. Also, what we added comprehensive plots. So you will see that there are most of the time that when you have reports, now it's become report and box plots, for example. So it will be more easy for you to understand the behavior of the data. So our summary or overview of the LaGriSU is that you have the toolbox here, which is contain the grid units and also the slope units, which is represented by four or five steps, okay, for each. It's very easy to go through with a very simple basic inputs, and it's most of the inputs are the landslide locations and the dam. That's all. So this is what you need to run this tool: landslide locations and the dam. So then you will have your inventory represented by, as you say, slope unit or grid units, and also in the end you will have your table that it's ready to be extracted. So this is the CSV file that you will take it later on for the machine learning algorithms. Okay, so you will have your entire data set well prepared and also represented by either grid units or slope units. One of the updates that we have also in this version, that we are dealing now with QGIS 3.14 and 3.12, 3.10. So before we were using just 2.16. Now we are able to run under the 3.14, which is this is I think the pi. Okay. So also we will show you how to download and support the models inside of it. All right, and this is the version that, for example, that to 3.14. Here you can get it. Also, we will show this in the during the course. We will show you also how to download it, and then as well as if you are not able to follow the Udemy course, you can also go through the GitHub website and you will find this tool here. Okay, so you can also use it and go through. But if you want to follow me step by step, okay, then you can go through the Udemy course, and we will start from the downloading the data, the software, setting the environment, and then we run the tools one by one and up to get the last results. Another update that now our tools working on the Ubuntu, okay, the Linux, and also work on the Windows. So now you have both operating systems supporting this tool, that you need just to install the QGIS inside the Ubuntu or Windows and run everything even offline, and you don't need anything else. You don't need to do any kind of programming or any scripts. Okay, so now here I will shed more light on these assumptions and the updates. So the major updates, as we said, about the landslide-free areas. So as we said, the buffer zone, which is the first assumption, it's based on the effective buffer around landslide events. So either we have the grid units, okay, the points or polygons. So this is free areas it will also apply for the slope units and grid units. All right, so this is as we said, it's a full course. We'll cover all these aspects. So as you see here, those shaded areas and this free areas. So here, this is our landslides locations. This is in case you are using the points. So here, this is the buffer that you are assuming it. For example, here we assume 250 meter. So 250 meter from these points, or in case if you have the polygons, okay, here in case if we have just only points, you can see it's uniform buffer around these points. But in case you have polygons, so when you have the polygons, you see here now the buffer become following the shape of the polygon. So then later on we will randomly select points within these safe areas. Okay, as you see here, this is the case. Okay, and also in this case, you see here now those, when we follow the grid units using the polygons, so we will have a group of grid units. But here we have this kind of representative also. It depends on your data. Both we will discuss them and we will explain them comprehensively. The second assumption for finding the safe areas are represented by the threshold of the slope and integrated with the buffer zone. So you might ask here, how can I understand, or how can I know that the safe slopes, which is simply can be done with the GIS by finding the slopes that doesn't contain or do not contain landslides. So we will help you here with this nice representation. So the tool will show you the box plot. If you see here, this is the box plot. It's drawn using the ID. This is the represent ID of landslides. Okay, and here this is the slope degree. Okay, so here you have the slope degrees, and we saw that using our data that the landslides started from the 5 degrees of slope, okay, and end up within 37 degree of slopes. Okay, however, the first quartile of the data, it's accumulated, started from the slope of 10 up to 21. So that's mean the first quartile and the third quartile that we have our data from 10 to 21. This is the, as we said, the critical slopes values. Okay, so before the 10 we have a very low amount of points, which is not even, if you see here, the major part of the points are accumulated from the 10 to 20 slope values with the mean of 16. Okay, so now based on your inventory, we will try to consider the threshold, okay, from 10 and below. So this is the threshold. So we will assume that any area below the 10 are considered to be safe. Okay, so this is the assumption. So yes, you have some landslides here, but those landslides compared to the other inventory, actually, because there are too many assumptions about this to say that there are no exact inventory, or there are no, let's say, an inventory without uncertainty, okay, or there are no perfect inventories. So all the inventories that you find, even about your study area, it might go back to like 50 or 100 years old. But what about before 100 years? Are you sure that this area didn't witness landslides? So when you take the buffer around these regions, it doesn't mean that this area out of the buffer are safe, because this is just depend on the inventory. Okay, so in the integrated here, we will try to be firstly far from the landslides locations within a specific buffer. Okay, and then also try to avoid the most active slope values or slope areas within 10 and more. Okay, so from here to here, this will be active, avoided, and from here to here, this will be safe. And this is a sample of the results. So you'll see here those shaded areas represented by the safe landslide slope threshold. Okay, and these also yellow objects represent the training or the zero data inside these areas. This is a sample of slope unit. Okay, so as you see here now, the slope unit, this is the red one, and far from these slope units also we took the buffer and we generated those slope units within the safe areas, and then after that we created or selected randomly the zeros values. Okay, and here also another example. If you see here, this is the zeros represented by the center of the landslides. This is the polygon represent the landslide, and below it, it's the representation of the slope units. So the slope units, we took the buffer around them, and also after we take the buffer, we ignore all the areas that you see here. This is the same region. Okay, we consider only the slopes within the 0 to 10, for instance. Okay, so at least we assure that we are safe enough for this specific assumption. All right. This is another example of using the landslide points and slope units. Okay, this is again the buffer, as you can see here, and these are the, let's say, the zeros value, and this one represent the one value. Okay, represent the landslides location, and here represent the training data for the non-landslide locations. And here also when you can see how we generate these buffers around the points and around the polygons within the slope units environment. Here also more examples about the output of the algorithms. For instance, this plot is the slope unit output. If you see here, this is our study area represented by slope units, and from these slope units we are selecting the active slope units that it's overlap with the inventory. Is all automatically done within the just 4 steps of the tools. Okay, and here again another example that you have the buffer around these slope units, and after the buffer you are creating randomly, or you are selecting randomly from the network of the grid units the safe one, which is usually we are selecting the same ratio between, if we have like 50 landslides, we are selecting 50 locations to be represent the non-landslides. And then we are using the training and testing data. So also we will produce this training and testing data within the course. Another update for this version, as we mentioned before, is the homogeneity and sensitivity. So to ensure that in the outputs we will not have something like this. Let's go back to this. For instance, in here, if you see the slope units look like uniform or look like natural, but in some places, if you see in here, for instance, there are elongated shapes, which is we don't have. For instance, yes, here, if you see, so in here as well. So these elongated shapes actually they are considered to be kind of error, but usually in the literature or in the available tools now, you can witness this kind of things very common. That's the issue. In this tool, we produce something we call it shape index. Shape index is kind of a filter that will be applied on the data to select only the shapes that approximately uniform. So how does it work? We take the relationship between the perimeter of the slope units. Okay, so first of all, we are generating the slope units. Then later on, the tool will try to take the perimeter of all this of the single slope unit and divide by the area of this specific slope unit. Okay, so as you see here, this is the perimeter and also the area. So by doing the formula here, we will have a specific shape index. If the shape index in the perfect manner will reach to 1, this represented by a circle. So the circle has a value of shape index 1. And once it starts to get a bit more deformed, the shape index get higher. So the square is 1.27 and the equilateral triangle is 1.6, and then the number will go on. So in our cases, actually, because this is this kind of slopes, so we will have like different sort of slopes, and some of them they can be long ones, some of them they are like, for example, they are short enough. So in this case, we try to reach into a specific number of shape index. So we assume like 6. The value actually, as I tested here, you can try actually. You can try within 5, 6, 7. But when you increase the shape index, okay, and when you increase the shape index, the deformation will increase. Okay, so what we say here, that the shape index will help us to produce more uniform sizes and better regular shapes, and be sensitive to the variation or the terrain variation inside the slope body. So and here also you can you will ask, how can I determine actually the shape index value? Maybe my slope units, they are like highly deformed when they are like 6 and more. When I assume 6 and less, I won't get anything, and this makes sense. And that's why we are producing the box plot as well. You will see here, this box plot now will help you to understand your data. So first of all, we get the slope units, you see, for the study area. All right, and then after we get the slope units for study area, we are producing this box plot for you. So from the box plot, you understand that this is the shape ID for the slope unit and the shape index. So you can see our data. It's vary from 2 up to maybe 3.7 or something. So this is the most common shapes in our slope units representation. But you can say that I don't want to have this kind of shapes from 4.5 or 5 and more, because here you have what does mean we said here you have more deformation, this kind of things. But when you get low, you will have something like this. When you get more, you start to get something more uniform. Okay, and when you get here, you will get something like this, let's say. Okay, so it depends. So when you assume your value to be, for example, very small, let's say less than 3.5, then the tool will not find this kind of shapes, because it's a little bit not natural. What will happen? We'll start to have missing data. So in this result, we use shape index less than 3.5, and you see we start to have missing regions. Okay, but if you try to follow the box plot, as we said, you try to go with something meaningful. So when you see your box plot, the maximum value, for example, it's 3.5, or in another case, when we go to the exercise, and you will see how much we will get, and then we apply. So when you apply now 4 and then 5, try to get increased more. You try to fill up those gaps. You see here, it's filled because we increased the number of shape index. Even though when we increase it, we start to have this kind of deformation. You see here. So when you apply low shape index, the algorithm try to avoid to have this deformation and attach it or dissolve it with the neighbors. Okay, as you see here, now it's gone. It's available when we have more than 6, but when we get very low one, it is already dissolved with the neighbors. In case that your slope, your landslide inventory, if it's, for example, you have 50 locations, 50 landslide location, and when you get the slope units, they're also equal to 60 or more. I mean represented all the landslides location, then it's fine. You can continue with this value. But when you reduce the shape index to less than the natural shapes, and you start to have your landslides, for example, in here, when you have no mapping units, that means those landslides are out of your study area anymore. Okay, out of your mapping units, it will not be counted. You will lose those points. For example, here, what you should do, then you should increase the shape index to have something like more, to have more slope units, and then you can choose your slope units for the inventory. So low value of shape index is equal high missing slope units. All right. So we come to the end. This tool is available, free to access, free to download, free to apply. It's open data for you, an open tool pack. You can go to the github.com alt20, and you will find that you will search for the LaGriSU. Then you can download, and you can install it inside QGIS. It will come up like this, and then you can run it smoothly in the GUI. But if you are going through the course for the Udemy, we will go step by step together to run using the GUI. Then we try to also have insight about the back end of these tools, because as we said, these tools are built inside the QGIS processing tools. So we will explain some of these critical tools for you in case you want to modify, or you need to change it, or you need to add more kind of things. And then we will use the data that we provided, and also the question and answers that you might face, or you have any difficulties, you can send it to the instructor, and I will try to be with you to solve whatever we can do. Okay. So thank you very much for listening to this updates. And if you have any queries, if you want to use the free version, as we said, you can test it. Even you can use it in your publication. All right. And you can also write me in the Q&A sections, or you can join our research groups in SCAD Academy. And if you are coming to the Udemy course, so let's get started. Thank you very much.